Hey class, this is the last gas law for this unit, and it's called the ideal gas law. This one has every single variable that we've talked about, but it's not as difficult as it seems. First off, let's read the question. A container of 3.8 liters has a pressure of 2.1 atms and is at 38 degrees Celsius. How many moles are in it? So first off, we're looking for moles. And remember, moles is represented by the letter N. So question mark N. Next up, we want to identify our formula. The formula for the ideal gas law is PV equals N RT. P being pressure, V being volume, N for moles, R is our universal gas constant, and T is temperature. And remember, that's in Kelvin. Now, we want to find N, so to isolate N, we have to divide both sides by R and T. That cancels out this side and leaves us with N equals PV over RT. And now we're simply going to plug these numbers in. So our pressure, 2.1 atms, times our volume, 3.8 liters, divided by R. R, when we're using ATMs, and for our test and for this unit we will be using ATMs, is always equal to 0.0821. Always. So plug that in right here. 0.0821. Now T. Now again, earlier I said it has to be in Kelvin. We need to change this Celsius to Kelvin. Do you remember how to do that? We take Celsius plus 273. That gives us 1 and 1, 311. So 311 K would be our temperature. Now we're going to multiply the top. 2.1 times 3.8 gives us 7.98 over 311 times 0.0821 is 25.5331. Now we have to divide these last two to get our final answer. 7.98 divided by 25.5331 gives us a grand total of a lot of decimals. 1253549. 1253549. Obviously, all of those aren't going to be necessary, but how many are? 1 decimal, no decimals. We're going to round to just 1 decimal. That 3 is going to stay the same. So our final answer is 0.3, and again, we're looking for N, which is moles. That's it for gas. Next up will be solubility and solutions calculations.